Thank you. Welcome everyone to ACDE number 206. Obviously, on the agenda today, we're going to talk about what happened on Holesky. That might take up most, if not all, of the call. But if we have some time left over, there were a couple Fusaka-related topics that were on the agenda as well, and then some questions around EIP 4.4's progress and statelessness. So to give a bit of context to anyone who's listening who may not have followed what happened this past week, we had the fork scheduled for the Holesky testnet. And then shortly after the fork, which happened on Feb 24th, we realized that some of the execution layer teams had not set the right address for the deposit contract on the testnets. The deposit contract address is different on Sepolia, Holesky, and mainnet. And then because they hadn't set that, now with Pectra, that deposits can be processed directly from the EL. They interpreted a block with deposits differently, where the ones that had the wrong address just ignored those deposits. This led the network to fork, and the and this issue on the execution layer side was caught fairly quickly. But then, because there was this massive fork where the three execution layer clients that represented the vast majority of the stake were effectively off the main chain, it was quite hard on the consensus layer side to actually get validators testing and building onto this chain. So for the past few days, we've been trying to get there. It seems like the chain is progressing now in a, quote, relatively smooth manner. But that's a high-level overview of the situation. And then in the agenda, I've linked ongoing postmortem that goes into more depth about the technical causes. So I'll pause here. Does anyone have a status update on like the health of Holesky right now? I saw Nethermind before this. Oh, sorry. Yeah, go ahead.
Yeah, I can go for what we have on Nethermind side. So we fixed our infrastructure and we are running more than 100,000 keys right now and proposing blocks very smoothly. So it's good. And we also spinned up few nodes for a better peering. And I, not personally, but I saw the check from one of users on Discord. We are proposing like 65% of blocks. For 65% of slots, we have blocks. So it is way much better than it used to be even yesterday. So things are getting better and better. And hopefully we'll reach like 75% even today.
Nice. Anyone else? Does anyone know if the PK Dora is still on the right fork? Okay, yeah. So that's what I was gonna post in the chat. Yes. Okay. So this is still on the right
Yes.
fork. So going through it, it looks like there's a good amount of proposals coming in. Yeah. So I guess, has any team not been able to get back to a spot where they can actually propose a block? I know certain operators might not be, but like, has any client team not managed to get their validators back online? Okay, Prism has some, but not all. But yeah, every team basically has at least a subset of their Holesky node, Holesky nodes back online.
Yeah, Basie's got all of our validators back online and pursuing head.
Got it. Okay, and then Nimbus as well. Okay, so it seems like, yeah, pretty much every team has at least some validators back online, and some teams might not be not be fully there yet. Trent had a comment in the chat noting that there's only like 10% attesting to every epoch. This is basically expected. So again, for context, because the quote valid chain was a very small minority chain, there's only about 10% of the stake on it. So what needs to happen now is that we effectively need to leak or slash the validators on the on the majority chain until the minority chain that is correct gets back to 2/3 of the stake. And I personally learned this week that even if you're a validator who attested to an invalid finalized chain, you can still propose on another chain. So this is why we see a larger percentage of blocks being proposed than of attestations being collected per epoch. Okay. Oh, nice. And then Rafael says, okay, based on the last 500 slots, there's 44% of block production at the moment. So yesterday we had a call to discuss how to effectively recover Holesky. And the idea was that once we reached about 75% of blocks being produced, we would start coordinating slashings and slowly process them. And then we also said that if we didn't get to 75% overnight, we'd figure out what to do on All-Cordes, which is right now. So assuming we have about 44% of blocks being produced, how do people feel about next steps here? Should we start coordinating slashing? Should we wait a bit, let the change settle? Roman?
Did anybody follow up with Michael and Depline from Lighthouse, who said that basically there is an alternative proposal? If we enable all of the validators at the same time, we might be able to finalize quickly.
So we talked about this internally a bit. It would require people like patching their nodes to not slash. The idea is just to like have even validators who would be slashed just a test to help us finalized without actually slashing them. Yeah.
Oh, okay. Because Michael's initial message made it seem as if we don't need to ignore slashing, but we just enable validators quickly and we might be able to finalize.
Oh, interesting. I might have missed that one.
POTUS?
Yeah, so there seems to be a lot of confusion around what are the mechanisms to recover. So first we don't need to leak anyone. I mean, leaking might recover the chain, but that would take months. And we are kind of certain that we're going to die before we reach that point. Second, we can and we do not need to write dispatches to avoid slashings. If we just set we coordinate at starting with this epoch, we are going to attest all of us, then those attestations will get in and we will not slash as many validators fast enough. So that once these attestations get in, which is going to be like all attestations from every validator that sets it at that epoch, then we're going to justify that epoch. And we need only 2 epochs attesting from these validators to finalize that first epoch. And we will, I'm sorry, I think it's Katya.
Katya, can you mute, please?
Yeah.
Sorry.
All right. So the point here is that if we arrange to have at a particular epoch and spin up all validators, I mean, kill all slashing DVs, and we test this before so that we make sure that we know how to do this in a timely manner, then we will finalize within 2 epochs, and that's it. We just move on. Then the slashings can be processed very slowly, and that's not a problem. But this requires coordination. This requires that every validator sets at the same time in the same epoch.
Okay, and this is different from Paul Harris's proposal from yesterday, where we enable only, we disabled the slashing protection only for 1,000 validators at a time, correct?
Yeah, that's definitely a bad idea. That's going to slowly that's going to create load on validators by like having to process slashings, and that's only going to leak slowly validators, and we're going to have to rely on leaking to finalize. We can rely on the fact that attestations are good as soon as they are seen, and then we remove the balance from these attestations once we've seen the slashing. And since we can only slash as many little many validators per block, we cannot slash them fast enough. So if we have 75% of the attesting balance attesting, we are going to finalize. But the problem is that, well, I'm not really sure how much we can actually expect to have 75% of validators active.
Yeah, right now, if we look at the block proposals, assuming that's 40 something percent, I expect. Oh, and then someone in the chat is posting 60, 65. So I assume that's basically an upper bound on what we can expect for participation.
Yeah, so we need a buffer well over 66% if we want this to work. And I honestly think this is the only way we're going to save the chain.
Okay, so if we were to do this, then like, yeah, the next step is figuring out how do we get how do we get to that level. Oh, and then Jim is saying that this will only work short term because over a day all the validators will be slashed, and that the lecture allows for many validators to be slashed in a single slashing due to change attestation format. Does that change
I might be missing
your...
something, but that's my understanding is that even if we bring all the validators online, we're going to start seeing high numbers of slashed validators happen relatively quickly. I mean, Potters, am I missing something there? But you know, again, with the electro attestation format, you can slash thousands of validators in a single attester slashing.
Yes, but because of shuffling, you won't have enough in intersection into attestations to slash a lot. So you'll have just a few, like maybe 100 validators, or maybe more, but it's really a relatively few validators in the intersection of two slashable attestations. This is why it's gonna take time.
So we don't really, I mean, considering that we had justification on the other chain, there's going to be a number of attestations out there that are slashable that have a large amount of validators in them, right? So, I mean, I get it. It's not going to be like a perfect overlap, but it's probably still going to be a relatively high number of validators potentially being slashed each block. I mean, even if it's not, say it takes a week, you know, we're still going to be at the stage, if it's a week or a day, it doesn't matter, where enough validators are being slashed and we've lost finality again, right?
Yeah. So what Spot was saying is that we can finalize, but then once we slash everyone, it will happen anyway, but it will take time.
Yeah, so what we want is to finalize something, one epoch, and that's it. If we lose finality later, that's not that much of a problem. The thing is that once we finalize, then we're going to alleviate CL clients because we can now checkpoint sync on a closer checkpoint. It's fine if we lose finality later.
Right.
But I think Jim has a point, because if we can pack many attestations in the first couple of epochs, then we might actually lose the finalization in the second epoch already.
Right, so you need to have enough of the stake or the stake weights to actually finalize over 2 epochs before you go back down to 66% due to slashings.
Right. So we want to process 2 attestations from each one of these validators.
Right. And because of shuffling, again, it will probably, in the worst case scenario, it could take like 1,000 slots because we have just one slashing per slot. I mean, like to slash all validators that are slashable. It'll take a long time.
And what would happen if slashing happens too quickly? So say that we get everyone back online, they attest to like a first
So if
epoch.
slashing happens too quickly, you're going to have to leak those validators. So if slashing happens quickly enough that we don't count the slashed capital, the slash balance for the current justification, then we're not going to reach what we need. And we're going to have to leak, process all the slashings, like exit those validators. And then once like all of the active balance actually goes down, then we might justify later on. But I think that's going to take a long time.
And was that basically our plan? Like,
well,
that
our hope
seems similar
was
to the
that we
previous
could
plan,
finalize immediately. The hope would be, let's finalize immediately, and then we'll leak. And that, we don't mind leaking after we've finalized.
Okay.
Wait, why?
So
It will take nearly the same amount of time to leak out. A bit less because of correlation penalty will take place for 1,000 epochs after the slashing event, but we will not be able to finalize during this period of time, which is 18 days.
And that's, I guess, the worry, right? If we're suffering the way we're suffering at the moment after basically 4 days of finality, do we think we're capable of 18 days or 21 days, depending on kind of where we end up, right? If they act, because bearing in mind the other point is the validators that aren't attesting are in activity leak at the moment. We can reset that clock by getting finalization, but it'll start again. So inactivity leak's about 21 days to get to 16 ETH. As you mentioned, Miguel, if we slash lots and we're 18 days roughly before we get to the correlation penalty, it seems like we're better off getting to the correlation penalty sooner. So I understand this idea of slashing slowly and similar, but it seems that if we actually are going to be in trouble regardless, it sounds like if we get the vast majority, if you get a third of our validators slashed, right, 18 days later, their balance goes to zero, which means they're not part of active balance, which means theoretically the remaining ones should be able to pick up a little bit quicker. Otherwise, we're looking at inactivity leaks of 21 days or similar before it even gets to 16, and that still counts as active balance because they're only exiting and not exited. I get what we're trying to do in the next day or two. I don't really get what we're going to be doing for the next week or two after that.
Yeah, but Jim, the problem we have now is it's an issue that we are still getting a lot of batches that are based on this invalid branch because peers are serving those batches, and then like syncing in that scenario and starting a client that is trying to sync from the last justified checkpoint is the problem. If we finalize, we are going to be in a similar scenario, but now every batch that we get is going to be a good batch. We're not going to be blacklisting peers because every peer is going to give us a good batch. So that's, I think the best we can hope now is we finalize something on the good chain, then that'll alleviate, like restarting nodes will sync immediately from checkpoint sync, and then we leak them slowly, and we hope that clients will hold on the single good fork.
Understand. Okay, yeah. I mean, that makes sense. As we said, if it's the best we can pull off, that's okay. And I guess the other thing it does is it buys us time to look for clients. I know Lighthouse, for example, have released a new version or a new patch recently that gives them more ability to handle longer term lack of finality. So maybe if that's what we're doing, we're buying the time to allow us to do that. And as you said, getting a reset to avoid more forks. Okay, that's reasonable. I just think it's probably important to make sure it's clear to people, though, that it's not like we get to finality and we're done. It's still a long road from there.
We can keep fighting once we get to finality. Yeah, Terrence?
What does the social coordination look like to have everyone turning off slashing DB at once? Because I don't think this is something that we have done before, right? And something we probably want to code this assumption into the code itself, because if everyone does it like manually, that we may miss a few epochs here and there. And I don't know, maybe we don't have to have an answer for this code, but it's something to think about. Maybe we can carry this offline.
And the idea for the slashing DB is that we want to get up, sorry, just to make sure I understand, we want to get up to a point where we have above say, a large margin above 66% of validators online, and then in a coordinated way, we get all of them to turn off their slashing protection. Is that correct?
Correct.
Yeah, okay. Yeah, Enrico?
I was just thinking about this slashing DP erasure. So this should be fast enough and well coordinated in a way that clients should be able to actually do that without even restarting. So I don't know if clients require restarting, then we end up in a messy situation where we could start losing blocks and we are not healthy enough to work anyway.
So that's probably a conversation for, well, there's three aspects, right? We've got two aspects. We've got remote signers, which are Dirk and Web3 signer, and we've got local databases. So anyone running with Dirk, we can remove the slashing DB, basically shut the process down, remove slashing DB, restart. That process end to end is probably one that takes about 5 seconds, something like that, right? The startup time is relatively minimal because there's like a batching system inside Dirk to basically take all of the individual keys and encrypt them under a single entity. Does Web3 Signer have something similar, or can it remove the slashing DB hot?
Yeah, it's more clients that are single clients running DB in a single process, essentially. So you have to recycle the beacon chain itself, and these kind of setups are a little bit clunky.
Yeah, and for Prism, for example, restart would take a very long time.
So is that a restart? Would that restart for you be validated client only? Would it be the beacon node as well?
Right. This is just restart of the validator client, so it should be fast.
Well, depends on your setup. If you have nodes that, so we have to migrate all the nodes to have separate processes. So you have validator client and beacon node. So if you want to restart, you can restart validator without losing your backend beacon node, which is probably so we need to migrate all our setups to a stable situation where we can do this quickly without restarting beacon nodes.
If you had to restart as is, how long would it take?
Well, it takes a situation where you probably are gonna miss time slots initially. So it depends now currently. So I think that the beacon node will become fully functional, hopefully in few slots. But it could happen that you can be slower.
I mean, that doesn't seem unreasonable to me. I'm not sure we're going to coordinate down to, within a few slots anyway, a few slots. We're talking about half a minute, a minute. I mean, people are not going to coordinate exactly to that point regardless. So I think, as long as we're not in a situation where someone is individually decrypting each of 100,000 key stores before they start their validator client, we're probably in a reasonable place. As long as the beacon nodes again have got suitable peering when they first start up, and obviously we've got a list of VNRs for that, right?
Everyone restarts in the same moment, you could have even problem peering.
Also true.
The safest way is to have a separated setup with two different, beacon node and validator client, and it will be much easier, more stable.
So we probably need to get we're going to need some document to track this. But again, all the core devs out there who are running 100K validators each, we need some vague idea from them about A, if you restart, how long do you think it'll take? B, if you restart, does it require you restarting your beacon node as well? Because that's a very good point, that if obviously everyone sits there and restarts their beacon nodes at the same time, all the peering will just vanish.
Yeah, Boris?
Yeah, so there are some features that we proposed and we haven't really merged them yet, luckily, which are if you catch a slashing event, a slashable offense on the flight, like for example, double proposer, then submit the slashing immediately. So do not rely on the slasher. And then the other one is if you catch a slashable offense by one of your validators that you're serving, then stop serving everything from that node. That will kill us if any client has actually implemented this and it's live.
Oh yes, we have it. I need to check if it is default on. I guess no. Hopefully.
Yeah, if we have this defaulted, then anything we're planning, it just goes to trash.
From our side, just a note, if anyone's running what we call ESD, the emergency shutdown daemon, that's exactly what that's designed to do, but it's an external process. It's a sidecar on purpose. So if it is out there and people are running it, then if you kill that, then that will obviously stop our nodes or similar from shutting down. But yeah, that's only obviously applicable for people running that.
So I guess the other option here, so like the reason we're doing all of this is that clients have a strong assumption around like using a finalized block as a sort of a checkpoint on which to build. The other, I guess, path here is it possible for CL clients to effectively set an arbitrary block and use that as like their starting point? The same way on the execution layer side, where we have like this set head feature where you're able to like force your clients to a minority chain or like I guess post merge an arbitrary chain and say like I want to just care about a chain that has this block in it. But would it be possible for CL clients to coordinate on a specific block and say, we will just treat this as like finalized for the purpose of sync and peering and all of that, rather than like going to your peers for one? Because like, yeah, there was a comment in the chat as well around like, what would we do on mainnet? And then like, my sense is if this is already hard to coordinate on Holesky, it's extremely unlikely we'd do something like this on mainnet, whereas you could imagine socially coordinating around a specific block or something and use that to use that to effectively sync or to be like your anchor for sync. Or are there other options than POTUS's plan, basically?
Is it okay to say it's a bad plan, but it's the only one we have? I mean, we're in a bad situation, right? I mean, there's getting finality is good because it gives us everyone a point to work from. Beyond that, at some stage, these validators are going to go away, either being slashed or leaking out. So I think, yeah, like we said, it doesn't get us to some sort of happy ground immediately, but it's certainly the best thing we have to do at the moment.
Thanks, Terrence.
Yeah, so like POTUS plan doesn't make anything worse, right? Because if it doesn't work out for, say, if we screw this up, then we're still back into the non-finality thing, and then we still let the validator leak out one way or another. So yeah, it's just an additional step that we have as a guarantee that we can start with a nice finalized checkpoint without having to black this peers from the beginning.
Okay, so if we wanted to go about this, then yes, we need to coordinate with all of the different Holesky node operators, have a clear guide for what they need to do. And then in parallel to this, we also need to bring up more of the existing Holesky operators and try to get the stake back to well above 2/3 online. What's, I guess, in terms of actual like things to do, like I assume the main thing is to just have a clear guide for how to disable slashing protection for whatever setup you're using, and then agree on a time to do this, and yeah, have people do it at the same time. Is that like the right approach? And then what's the timeline? Yeah, so I saw Merrick's doc has some instructions. Like, I don't know how comprehensive it is. It is. Does anyone have a link to that, Candy? Oh, thanks, Merrick. And then what's the timeline on which this needs to happen?
Hopefully today.
Okay.
Today, tomorrow, hopefully.
Should we, like, yeah, do you think there's value in scheduling it in advance? Like, should we tell people to do this at 14 UTC tomorrow?
Well, I think there are
quicker
two
than that?
steps, right?
Yeah.
I think there are two steps. The first step is that to know there is sufficient validators online and proposing block.
Yeah.
The second is that figure out that epoch number to do this. But the question is that are we at the first step yet? Are we comfortable that there's sufficient block? So if that's not, then we cannot decide the second step.
Right. But then, yeah, can we make, like, yeah, I guess as we get people online, it would probably becomes easier to just say, like, okay, this is when we're planning to do it, and this is like your timeline to get this up and running. And worst case, we can abort. But I would lean towards trying to like packaging the comms and be like, okay, you need to do this by this time, and this will happen then. Yeah. Yeah, Solius?
So, if I understand correctly, the key idea here is to try to finalize again, just to help clients to function better. But the problem is that after this reset, assuming that it will go well, but I don't think so. I mean, there is just too much of coordination, and the setups with slashing protection is quite different among clients and signers and so on. So it's really hard to get it right, especially by tomorrow. But the key thing, so if we reset that, we finalize shortly, and then we again go to non-finality period, and this only helps us by a few days of non-finality, because it's like it happened like 3 days or so ago. So we just cut 3 days of that bad period, and then we will have a long period until we will get finality again. So I don't see that it's actually meaningful, because we will, in any case, we will have a long non-finality after that. So,
Yeah, Potus?
I mean, yeah, I just don't see that it's going to help a lot, even assuming that it will we will finalize soon.
Yeah, I agree that this is most likely going to fail. And this is why I actually support what Tim is saying of like trying to schedule this for like a time today and say, tomorrow, 14 UTC, we are going to start slashing ourselves. It doesn't matter if we reached 75 or 66 or 50, it doesn't matter, because even if we do this at a coordinated time or roughly coordinated time, and if we don't finalize, at least we're going to get the correlation penalty to apply, and we're going to just see if we can manage all of the slashing and leak the fastest possible that we can at the current situation.
So, okay. And so just to make sure I understand, this means that if we try to say schedule this for tomorrow, if things go well, then we've finalized and it allows clients some breathing room to build on top of a finalized chain. Like Solius was just saying, though, it'll be kind of short-lived breathing room because we'll get to a non-finalized state probably minutes, if not hours after that, and have to stay there. If we don't finalize, then it means we're effectively just moving through with the slashings and waiting on the leak. And we feel that the like small chance of actually getting everything finalized and providing some breathing room to clients is worth the coordination costs. Is that correct?
Well, it's just that, I mean, in the worst case scenario, what's going to happen is that we're going to slash a lot of people, and this actually also helps with the leaking.
Yeah.
So
I guess if that's true, then why wouldn't we just start slashing like right now?
Because if we try to reach a high percentage enough that might allow us to finalize, that's going to help us. But if we start like leaking now, if we start like slashing right now, we are certain not to finalize.
Yeah, and
my point, I guess,
is
capital.
Yeah. What is when you say it's going to help us to have finalized, like, you know, there is a finalized block that's like probably 5 days old at this point, and clearly that's no longer useful. What I'm trying to understand is what's the extra value of a finalized
The extra
block?
value is that we do not need to start banning clients when we request batches. We are never going to get a batch from an unfinalized section that is invalid. So currently, when you try to peer and you try to sync a node, you spend a lot of time until you find good peers, because there's a bunch of peers that are still trying to feed you bad batches. Okay. If we finalize something further down, even those bad peers will no longer serve those batches.
And I guess, sorry, and then one of the assumptions here is that the peers right now feeding you bad batches have run the like buggy execution layer clients. Whereas if we finalize a new block on the correct chain, it means that even though we're building on a non-finalized chain, because we've patched the execution layer clients, everyone sort of agrees that this non-finalized chain is valid and there's no longer like a competing chain. Is that correct?
Yeah, but we're still peering with those guys, and those guys are still feeding us those batches.
Yeah. So, but if we finalize, then you're able to say, hey, here's like a finalized block on a chain which is correct, and therefore you can ignore any peer on the justified chain.
And,
that's okay.
And
okay,
moreover, peers that are on that other chain, either they will switch, and even if they don't switch, it doesn't matter because we're no longer going to even peer with them.
Yeah. Okay. Okay. So finalizing, basically, like finalizing a post Petra block which is valid allows us to manage a peer-to-peer network better. Let's do Mikhail, and then Daniel. We should do your question as well. Mikhail.
I just wanted to add that if we finalize something and then as soon as we can slash everyone after finality, we will have like roughly 18 days of non-finality versus like if we just leak out non-participating validators now, it will probably take 6 days longer than these 18 days. So I don't know how much of additional stress clients will take in the second case, in the case of leaking out, versus like this short path to to recover. I don't know if it matters, but this is something that might be substantial, like 18 days versus say 24 days of non-finality.
Anyone have thoughts on this?
I think the numbers check out, right? I think that's it is the right thing to do. If once we've got a checkpoint that's past the fork, I think, yes, slashing everyone as quickly as we can makes sense, because the other thing, obviously, if we get a third slashed within the 18-day period, then as each validator comes around, it gets slashed to 0, which obviously removes the active balance entirely, which gives us better chance to finalization. If we're leaking out, even then we leak out after 21 days, we'll hit 16 ETH or whatever. They'll still be around in the active balance because they're exiting, not gone. So yeah, absolutely. I mean, I know some people are saying we should slash slowly. I think it makes more sense to slash quickly, because as we just heard, we are going to be better off with a shorter period of finality if we can slash more balance or remove more balance from the active balance faster, and slashing seems to be the better way of doing that than inactive.
Okay. So does anyone disagree with moving forward with this? Okay, it seems not. So next step are, one, to have like a clean doc that explains how to disable the slashing protection for every client, to reach out to everyone. Oh, sorry, Radek.
Yes. So my only concern here is, I think Dustin wrote this also on chat, is, is this really something that we can handle in mainnet, even if it happens? Meaning that, can we really have 18 days of non-finality on mainnet and not declare Ethereum dead? Because if this would require social coordination and reverting, because 18 days of finality is not something that realistically can happen, then even if we recover Holesky right now, we still probably would need to think, how do we change the spec, I guess, of Ethereum, I think, so that it's even not possible to have 18 days of non-finality. I know there are points for that, why we can't slash maybe too fast. But if such a situation like here is also not acceptable in mainnet, then we need to think, how do we change the specs so that we don't get into a position where basically Ethereum is declared dead and we need social coordination. Meaning that even if we recover Holesky now, and we need to change something in the future to prevent even what happened to Holesky now, then it means that all of the work that we are doing now is really not relevant to what can to any future because we still need to make big changes to Ethereum so that we don't have this sort of scenario in mainnet. So I guess my basic question is, even if we recover Holesky, can we reasonably expect that if such a thing happens on mainnet, people will allow us to recover mainnet like this?
So I guess, yeah, there's two things here. One is, are there changes we should make to the mainnet spec based on this incident? And I agree there probably are, if not at the spec, at least at the the client level. I still think, though, that going through and actually recovering Holesky is valuable because it allows us to find all these discrepancies. One of my takeaways so far is the ability of CL clients to sync to arbitrary non-finalized states seems extremely important, and that is something that could allow us to handle 18 days of non-finality better. So and we can get into the whole conversation around what's the economic model around 18 days and should that be changed. But if you take this for a given that there are cases where you would get 18 days of non-finality on mainnet, then we want clients to be able to robustly handle this. Clearly today there's suboptimal in that respect, and there's things that we need to do. For example, we could not coordinate all of mainnet to agree to disable their slashing protection at the same time, or to all get slashed at the same time. But this kind of buys us breathing room as we're working through this issue. So I think we're going to need to have a follow-up conversation around okay, what did we learn from this, and how should it affect the clients in the mainnet spec? But I don't think the work of going through this is wasted, because at least so far it's provided some helpful learnings.
Right, but one last thing, maybe, because before I let others speak, is that POTUS wrote on chat that on mainnet, people will not just allow themselves to be slashed. So the thing that we are doing now is purely possible on testnet, because just I don't expect everyone on the mainnet saying, yeah, sure, slash us now.
Right.
We are not going
yeah,
to wait for the chain to finalize. You can slash us so that you can recover the same way you did with Holesky. And in that case,
so what I'm saying is that
Mhm.
yeah, this slashing right now that we're coordinating effectively is a way to handle clients not being able to deal with unfinalized forks as well as they should. So you can think of this as like, yeah, because this is Holesky, we get to do this thing that gives clients breathing rooms, but we should not assume that we could do such a thing on mainnet, and therefore we should make the clients more robust, but we're not going to make the clients more robust in the next 24 hours. Yeah, so I think yes, we're not going to get a perfect replica of what would happen on mainnet, but I do think it highlights some of the failure cases we would see on mainnet, and that we'll need to address and fix in the next few months.
And Radek, the answer to your question is basically to review inactivity leak, because if someone's not going to slash themselves, that makes sense. But equally, if they're going to burn their ether down by not attesting at all, then that's the other side of that coin. So, and that's a lot of the conversation we've had in this hour, where we've been saying, do we let things leak out or do we slash them? Potentially, yes, increasing the inactivity leak, so clients leak out within 3 days rather than 18 or something, is an option. It's not a cost-free option, because it does increase the ability of a malicious actor to make the chain inactive, and obviously cost everyone a lot of money. So it's not without cost, but yeah, I mean there are certainly things that can be done. But I agree with Tim. It's worth doing this anyway, because if we can survive 18 days in on-finality, we could survive 5 or 3 or whatever we choose afterward. And so it makes sense to do this anyway. But yeah, I mean, certainly we need to have a discussion, I think, in and around if it makes sense for us to carry on within an activity league where it is, or if we should change it.
POTUS?
Yeah, so I added to the agenda something that you mentioned already. So I don't know if you want to discuss it later or if this is a good point, but you just mentioned this issue of syncing from an arbitrary checkpoint.
Yeah, please.
Okay, so yeah.
Sorry, before we dive into that though, I just want to finalize the plan. Or Sasha, were you gonna comment on practical next steps for this?
Yeah, so I lost internet for a bit, so I missed some things, but I just want to give the lighter point of view here, in the sense that even the sort of the non-finality leaking out over X number of days plan is not ideal for us, because we have not been able to test the actual hard forks, right? In between, a hard fork happened and our oracles basically stopped working because of no finality. And so it'll be hard enough to disentangle bunker mode for us without trying to figure out if anything broke or didn't because of the hard fork. So what that leads us is, it's not ideal at all, but from our point of view, if Holesky can't be saved, then waiting for a full Holesky-esque testnet to run the hard fork against is by far the safest option. A shorter-lived DevNet is better than nothing, but we won't be able to have tens or hundreds of independent node operators interact with the protocol, or be able to set up all the parts, all the monitoring, all the checks, all the infra. And even if we could, we might not see all the different types of event cases we might see as a result of full routine operations. So the thing about Holesky for us is it's more like a staging QA environment rather than a sandbox. So I just want everyone to sort of have that context there.
Right, and yeah, I think we can have a discussion after around okay, what do we want to test? We clearly lost some testing capabilities by losing Holesky. The DevNet will help with some of that, but not everything. I do think we probably want to have that as a separate discussion item. Roman?
Would launching a longer lived testnet within the next couple of days help in this case?
So I think one challenge, as I understand it, for like the Lido situation is that the DevNet that we're launching is probably going to activate Pectra quite early on. For something like Lido and probably a bunch of other projects, they'd like a testnet where like they deploy all their infrastructure, which was already the case on Holesky, and then go through the fork. So there's like a coordination difference here where like DevNet 7 will allow us to do some Pectra testing, like say validator consolidations and whatnot in a like post Pectra environment quickly. But it's different from saying, yeah, here's like a full staging environment for a bunch of projects that are already set up, that are already using it, and now they get to go through the fork. And then Sepolia does not provide that ability because the validator set is gated.
So I think we have to recognize that we've lost some ability for developers to test on Holesky, not least of which is that we're never going to go through a hard fork again on it. It's in Electra, it'll stay in Electra. We're not going to come out of that. But yes, I mean DevNet 7, I believe we've still got about another 4 days before it upgrades from Denkun to Pectra. So there is some time there to do that. I recommend, obviously, for Lido and for anyone else who's in that same situation, to do what they can in terms of getting stuff up and running on DevNet 7 prior to the upgrade. And obviously, if ultimately there's not enough time or similar, we could create a DevNet 8. Again, we understand it's not going to give you all of the users that you'd hope for, all of the tooling that you'd hope for, and similar. DevNet 7 was basically a response from yesterday to try. We're trying to give people what we can, right? I think what I would say is if there are situations that DevNet 7 does not provide for people, if it's upgrading too early or if it doesn't enough ether available to you or whatever else, I think just let the community know and we'll see if we can do something about it. We recognize Holesky is a missed opportunity for a lot of testing. I think we need to do what we can to patch it up where we can. But again, recognize we're never going to be able to roll Holesky back to pre-hard fork and upgrade it again. I think that one's just not available as an option.
I don't know. Maybe we can have Fusaka go on Holesky. That'd be a sign we've done this well. But and yeah, like there are different options here. It's like maybe we actually start a new quote like DevNet 8 and just fork the Holesky pre-Pectra state and something like that. So like I think there's options here that we should consider, but I want to separate this from the short-term like save Holesky discussion. It doesn't seem like there's any more objections to POTUS's plan. So just to reiterate, to make sure we're on the same page, what we would need is shortly after this call, a doc that explains how to disable slashing protection for all of the node operators and which versions to run to get online. Then we need to coordinate on a time. Okay. Yeah, we need to coordinate on a time for which to happen. I suggested 14 UTC tomorrow, but I see there's like the EPBS call and the Beam call. Do people want to do 15 UTC instead, or do people prefer to just?
It's not important, at least for the EPBS people.
What do you mean?
That we don't mind if it happens at the same time.
Okay. Yeah. So because like you are the EPBS person. So okay, then should we just do 14 UTC? We know this time works. Any objection with that? Or like, I mean, like, yeah, Terrence and POTUS, if you are going to run the EPBS call, we can just wait an hour later and do 15 UTC. I think it would be good to actually have people's like full attention for that 1 hour. So if it's easier to do that at 15 UTC, I think we should. Does 15 UTC work for generally all the client teams? And I think it would be good. So for tomorrow to have one rep from every client team who's knowledgeable about how to turn off the slashing protection there. Maybe what I would do is like, yeah, we should probably pick some time where like we agree, say like the call starts at 15 UTC, that like, 10 minutes after that, people disable it or something like that. I'm not sure what's the actual timeline that we want here in terms of like time to disable the slashing protection and all of that. But like, yeah, 15 UTC people would be expected to come in ready to do the disabling, and then yeah, like I don't know what ballpark is like the right amount of time, like is giving people like 15 minutes to do this correct, and then we spend the last 45 minutes observing or something. Is that reasonable? Okay, I will take the no objections as reasonable. And then, yeah, we can observe how the chain goes and take it from there. And yeah, thanks, Phil, for posting the doc. So like, I think this doc was maybe a bit, may not be fully up to date. So yeah, I think it would be good to just make sure that we have a doc that's like comprehensive and that has the latest information. I can put something together right after this call and share it in the chat, and then have all the different client teams kind of post their information there. Can
I steal a minute to talk about Sepolia? It's
yeah, can we just finish this?
Than a week away.
Yeah, I'll do Sepolia next, but let's just finish this to make sure we're on the same page. Anything else just on like the short-term plan for Holesky? Does this address like everyone's concerns and issues? Okay, so let's do that. And then yes, so next step, I think there's other stuff on the agenda, but I do think given we only have half an hour left, talking about Sepolia probably is what makes the most sense. We, like Jim was saying, it's scheduled for next Thursday, I believe. We have effectively a week until the fork, or sorry, next Wednesday. So we have a week before the fork, a bit less. Even though this like Holesky issue has devolved quite badly, the quote trigger incident on the execution layer side was quite trivial and easily patched. We have patched releases for it. And so right now on the EL side, if you've run one of the 3 clients that had an issue, you would need to upgrade. But if you're running Reth or Aragon, you would not. And then on the CL side, I'm not sure what that looks like, if clients have new releases and whatnot, but Sepolia does have a fairly small validator set. So to the extent that there are new releases to distribute, we can probably get the validators to upgrade quite soon. And then if we did decide to delay it, then we would need everyone to also upgrade to a version that removes the Sepolia activation time. So how do people feel about keeping or removing the current time?
I think yesterday so yesterday we sort of said, has anyone got any good ideas as to why we should not upgrade? Is there anyone out there who can come up with a reason for us not to proceed with? Well, that's exciting. So I guess obviously people are watching, right? So one thing I think we should see and we should confirm, every EL team should post their configuration for Sepolia so they can be cross-checked, either reference into the code base of their current release or wherever they store these files, wherever they store this information. It's worth manually cross-checking this across all teams and any external observers who want to look to make sure we've got that. There is a Sepolia Telegram group. I don't know if you want to have something on the Discord as well or instead, but certainly that information should go out there just so everyone can gain a level of comfort that the problem we saw on Holesky will absolutely definitely not happen on Sepolia. Obviously, we need to upgrade the Sepolia execution layer clients to the updated version with these patches. Consensus layer teams, it would be great if you could consider if you want to stick with a current released version pre-Holesky, and pre all these sort of minor patches that have gone in and similar, or if you're happy with going with a later released version, if there is one, and again, confirming either way. The upgrade is 7 a.m. roughly UTC on Wednesday, so it would be good to get that over the next sort of 24, 48 hours so teams can upgrade as required.
I think we need to do much quicker than this. Like, we should obviously update these 3 EL clients. Does any CL client need their release updated from what's in the blog post? And if so, can you get a release out like today or tomorrow at the latest? But if no one voices it now, I'm going to update the blog post after this call, and we'll say, like, yeah, these 3 EL clients need to upgrade. We'll communicate to the Sepolia validators. And it seems like Nimbus, Lighthouse, Prism are good. Is there someone from Teku and Lodestar? Not necessary for Teku, so Lodestar, are you guys good as well? Okay, so all the CL or Grandine.
Yes.
Yeah, okay, so great. So then I'm only going to update.
For Lodestar, it's 127.1.
Is that what's in the blog post?
It's 127.0, I just saw.
And you're saying 127.0 will not work for Sepolia?
There's like a weird edge case, which might not be triggered if you're a block proposer, but it's safer to update.
Okay, but I guess, is it recommended or mandatory as an update?
Mandatory.
Yeah,
okay.
I would say mandatory, yeah.
Okay, great. So for those 4 clients, Lodestar plus the 3 CLs who had an issue, I'll update the release. Lodestar and the 3 ELs that had an issue, I'll update the release. Everybody else will stay the same. We'll keep the timestamp the same. For the 3 3 execution layer teams, can you please post something in the Awkward Devs chat to just share like your current config for Sepolia? I think that would be good. And then we are not going to get an automated test check done in the next 24 hours, but at least people can verify that the configs are correct. We've already had some folks double check. I think Dano's gone through all of the EL code bases to double check, but it'd be good to just post it in the Discord. Felix? Oh, you're on mute. Oh, we can't hear you, Felix. Oh, okay, Felix is gone. Sorry. Yeah. Anything else on the Sepolia upgrade? Okay. Yeah, and I guess also worth noting, like, one thing, like, we will have people from Panda Ops and other fine teams monitoring the update as it happens. So, like, yes, if there is anything that goes wrong, like, our response time will be hopefully quicker and better coordinated than it was this time around. And yeah, Justin, Besu, Nethermind, and Geth, I assumed we're updating, like, the 3 clients that had an issue with the original smart contract addresses.
Yeah, I'm just saying that the blog post needs to be updated.
Yeah. So this is what I was asking earlier. After this call, I'm going to update it for the 3 ELs that had a bug and for Lodestar, and then leave all the other clients unchanged. Yeah. And I wanted to wait to make sure we didn't delay Sepolia, and then, we'd have to do a whole different type of announcement. So, yeah, I think we're good there. Okay, so we've only got about 25 minutes left. I think it's probably worth spending this time discussing some potential next steps in terms of addressing this issue, and maybe maybe starting like POTAs, you were gonna bring up syncing from unfinalized checkpoints. This feels like one of the biggest changes we would need to do. So you want to give some context on this?
So there are some changes that are on the specification itself that would help. Like Jim was mentioning, we need to address this issue that it cannot take so long to leak out validators, or perhaps changing the ejection balance, and all of these things that have been discussed that are at the spec level. This requires a higher fork. There are some things that are client-based feature flags that we can actually implement, starting to start from a particular head already loaded up in forward choice. This is something that Lighthouse does, and Prism doesn't because of safety issues. And we had it and removed it, and then we can deal with those things. But there are some things that are in the middle of them. And one of them is this thing of like checkpoint sync being a socially coordinated checkpoint, where we agree that the following, we are going to start syncing nodes from this checkpoint that we declare is the good branch, as happens now in Holesky. We can take any of these checkpoints that are not finalized and say, this is a good checkpoint, we want to start from here. But engineering this on clients varies in difficulty. So I can only attest for Prism on how Prism works. And the way Prism works is that it keeps a forward choice being a tree at which root is what we consider the finalized checkpoint. And it would be fine to consider an unfinalized one there, but it would just, we need to agree that these nodes will never sync a block that is contending to that checkpoint. So if we go this route with Prism, like taking a checkpoint that is not really finalized, but we have this finalized state for the corresponding checkpoint in our database, and we sort of like magically agree that this checkpoint is a valid checkpoint that is a descendant of that finalized state, we can verify this and we can start our forward choice with that checkpoint. But this would make Prism never ever sync a block that is contending with that presumed finalized checkpoint. If we agree to this, we can specify this out and we can change our code base relatively fast.
Is there, this might be a dumb question, but like, can you just take an arbitrary block and call it like an epoch boundary? So like, obviously one risk about this is like, like core devs feeding some malicious, random checkpoint or whatnot. So like, can we have this feature built in a way that like any arbitrary block, and potentially restrict this to like epoch boundary blocks, is valid? Or does this have to be like baked into the client somehow?
Well, I would take it as an actual epoch boundary block. We can verify that this is the case because we can take a block and we can actually verify this, that this block is a descendant of what we know to be actually finalized. We can take a state for that block. So we can restrict to boundary states, that's fine. But the problem is that this is an extra trust assumption, because now we are never going to sync a block that is contending to this. So we're going to manually say that this is final.
Yeah, but when you say we, I guess my question is this every single node operator making an independent choice, or is it by default in the Prism release? I think if it's
no, it's going to be every single node operator that says,
Yeah.
I want to start from this checkpoint and manually fit a state and a block. So just allowing operators to do this. I think it's something that is reasonable.
Yeah, exactly. So that's very different when you say, we're always going to exclude the block. Like the sort of uncharitable read there is like, core devs decide what the valid block is, and that's bad. But if it's saying there's a mechanism for every user to plug in an arbitrary block and state, that feels quite valuable. And I guess I'd be curious if there's someone who maybe understands both sides, but does this differ from like set head on the EL in any way? Because we effectively
it is different because you can set the head on the EL, but then the EL will accept a reorg to a contending head. Whether here we're going to set a block as being canonical, and we are not going to consider any reorg from that block.
And this is like, yeah, set head, like I guess the EL doesn't drive consensus anymore. And I'm not sure how set head would work in like a proof of work chain, but it doesn't matter much, I think. Yeah, Enrico?
So you're gonna think about this, implement this in a way that it is effectively finalized, but it won't be finalized. So in the peer status RPC, you still have the actual finalized state in the handshake.
Yeah, so I think the only change that Prism will need is to decouple the condition that the actual state finalized checkpoint is the root of our choice.
Okay. And what are you about to do in the peer-to-peer? So you actually you will be connected to a potential contending.
Correct.
So to a peer that is potentially give you contending blocks.
Yeah, correct.
Okay.
We could try to specify something that would be more useful, which is disconnecting this peer faster, but I don't know how to do that in any easy way.
Yeah, because if we could actually be able to detect that, and it is effectively a social finalized state, it's better to try to not being connected to that and reduce overall noise.
So I guess, yeah, does anyone think this is a bad idea to spec out? And yeah, to Mario's point, like, is this something that should be like standardized across clients, and then we can write tests for it so that we can make sure that clients can take an arbitrary block on a non-finalized fork and sync to it reliably? I think this is the value we get from having it spec'd out, is that like we can then have standardized tests around it. If it is a per client thing, that's fine too. Like we don't need we don't necessarily need like a shared spec, but there are parts of this sync that we do spec, and that can be helpful. And I think here,
I mean, it was such spec or not though. I mean, it just needs to be done, right? Like we said, we've got the use case. We found it on Holesky. Syncing to checkpointing from an arbitrary block allows us to get past a lot of the issues that we were facing. If we had that available, it would have made things here an awful lot easier. And the trouble, and there's a side chat going on. How do we allocate resources for this type of thing versus the next upgrade? But given that we have moved this from a theoretical could happen, good to talk about in presentations kind of thing to it's actually happened, I think that it's things like this are very, very important. Now I get the security concerns and similar, but it's not as simple as feeding it, right? You have to clear your database, you have to point to the right checkpoint URL, et cetera, et cetera. So this is an automated process. This is something that enables us to recover a chain in a situation where we have very few block producers going on and very, very little network connectivity far faster. So I think, standardized or not, personally, I think we should be standardizing flags and things, because again, a good example at the moment, you look at the recovery procedures, they're different for every single client. Flags are slightly different, which is fine. But for something like this, it's easier if there's a single add this flag to the to the client kind of thing, and it'll recover. That type of thing makes sense. I think it's critical that this is an example of the type of thing we can do to say this is what we are doing, not in this case to mitigate the problem from happening, but to allow us to recover if that happens again or something similar happens again. So I think it's very important that we absolutely do this. If we think the spec's suitable, that's great. But getting it done, I think, is very, very important.
Yeah, I'd agree with this, and I think there's like two types of issues that like will come out of this. Like some are like pretty salient, short-term, like things we need to address, and to me, those are the CL spec, CL sync in like a chaotic state, and then what Felix wanted to bring up, like standardizing the EL config files, which is kind of the root cause of this, and then obviously for things like, okay, if we want to review how the leaking penalties work, I think those are the types of things that like are probably less urgent, and then we can have a conversation around, does it make sense to focus on this now, or should we focus on shipping pure DAS? But it does seem like at the very least, like the two engineering root causes that are fairly straightforward to fix should be fixed. Yeah, POTUS?
Yeah, so there's another engineering cause that actually is what hurt us here. After the bug happened, when we tried to like sync immediately, in principle, CL clients didn't have any problems. It was only purely on the EL side. But there is a feature which is optimistic sync that doesn't just brought up in the chat that there are no tests for it, which is optional, but every client implements it. Otherwise, we can't really sync. But the thing is that if we could make optimistic sync actually optional for the node operator, that would have been much better. Because in this situation where you have this bad block that is justified, we did it. We restart our nodes. Now that block is no longer synced because we're starting with a new checkpoint. And then the nodes the CL client would import it from the bad peers, and the EL would accept it because it optimistically would accept it. If we had a flag to say, I only want to sync not optimistically, then we wouldn't have need to come up with these dirty hacks of declaring the block invalid. Like the vanilla client would have just spawned up with the flag to sync without optimistic sync. I think this is an engineering thing that we should implement.
And yeah, Sean has like a PR for quote pessimistic sync. So like, what's the overall, like how big of a change is this, and what's the overall quote like idea or yeah?
Oh, the idea is very simple. It's just do not sync a block for which the EL has sent you back as either syncing or accepted response. Just sync the block if the EL has told you that the block is valid.
How big of a change? Yeah. Like it sounds trivial when you say it like this, but am I missing something?
Actually, I do not know. Optimistic sync is incredibly pervasive, at least in our code base. It's everywhere. I'll need to review. I'm not really sure how hard of an easy change is this. I suspect it's not so hard, but I'm not sure.
Michael's diff here is very small, but I don't know if he got this working.
So
Go ahead.
I can comment on this, but I tried quite hard around the merge to do this. Now, the circumstances have changed. It failed on the merge. Spoiler alert. And I think the challenge is not going to be in the CL per se. At least I don't think, because it's not that hard to reorganize things to basically reject, but to treat syncing as something closer to invalid. Let's say. I mean, not permanent, but still. The problem I had was that ELs, because they snap sync, they will sit there and say syncing forever. It doesn't matter. What I tried, for example, was to have this where it would kind of sit in a loop. I tried a lot of variations. Here's one of them. It would sit in a loop and keep hoping the EL would take the hint to catch up. And then that was before I learned how ELs worked. And they just never would, because they won't snap sync at all until you feed them a block till near the end, 120 blocks or so. This is now not all ELs are like this, but some are. And notably, because as POTUS says, optimistic sync is so ingrained, this is, practically speaking, it is required. Like, I don't like it, but it is required. That's why Nimbus does it. So that's, I think the ELs are the bottleneck here, is the short answer, not CLs.
Lucas?
Okay, so maybe we need something more sophisticated here, because I think we have potentially two scenarios. Scenario number one is when EL needs to do a whole snap sync, which is, or something similar, depending on the EL, which is basically syncing the state, the whole state, right? And then optimistic sync makes sense to use. But then we have a scenario when EL is doing either some small switch from fork to fork, right? And potentially, I don't know, needs to reprocess, I don't know, few dozen blocks at most, or probably less, which doesn't make sense to do optimistic sync. So maybe we just need to be more granular on this, and that's it. And on the second scenario, when we are close to head already, CL should just wait for EL. And on the scenario that EL is doing the initial sync, then it doesn't make sense for CL to go to optimistic. So we just maybe need to be more granular here.
And then, okay, so in the chat, I asked, like, what does quote pessimistic solve that POTUS' checkpoint idea doesn't? And it seems like the biggest difference is just that the checkpoint one requires a custom user input. So I would lean towards short-term prioritizing having this sort of custom checkpoint sync, and we can discuss optimistic sync being more granular in parallel, but I think in terms of just like addressing the root cause here, it feels like this is a pretty useful feature that CL should have that is probably not extremely complicated to implement. Does that generally make sense? And then we only have like 7 minutes left, so I want to make sure we also touch on the CL config issue. But and we can obviously discuss CL sync more next week on the call. But I think as a practical action item for now, like working towards this custom checkpoint sync feels quite valuable. On the EL side, Felix, are you still around? Okay, I'm not sure if he is, but the idea, Felix's comment was that there's currently 2 different types of config files that ELs use. I think this like parity used to have one, and then Get had one, and then I believe now everyone except Nethermind uses the same format as Get, and then Nethermind is still on the quote like parity version. 1, is this correct? And then 2, if it is correct, is it possible for Nethermind to switch to the same as Geth, and then we'd have a standardized version?
So I think it is correct. Well, I'm not sure if everyone uses the same format, but Nevermind definitely uses different one. Few things on my side. We probably would still need to support multiple, allowing to enabling granular EIPs. So we cannot really, so we would have to kind of have some kind of extension to the GEF format or keeping both formats, which is not that great, but I think the bigger problem is that, in my opinion, it doesn't solve the root cause, because let me give you an example. Even if we use the same format, but for example, in our classes which deserializes, we have a typo in some name, we don't deserialize this format correctly, and we might miss it. So what I actually think should be the better solution is to use something similar as we have as fork ID. The problem with the current, there are two problems with the current fork ID, which is used for connecting between dev P2P clients, but this is less important. We are also using this to synchronize core devs between forks. We just check out if fork IDs are okay. But the fork ID has also two problems currently. Problem number one is it doesn't differentiate per EIP. So if we have one transition on fork ID on one EIP, we do not verify that we have it on, for example, on 4 EIPs. So that's potentially problem number one. Again, this is maybe Nevermind specific because we allow single EIPs as to being instructed rather than just using a fork number or fork alias for all of them. But actually, I would say this is the argument to going the other way around and to verify that, for example, if we say Cancun is enabled on those clients, what actual EIPs do they mean that they enabled, right? Maybe someone I misconfigured their Cancun alias and it does enable some EIP when it should. So actually going the other way around, in my opinion, is better. And the second problem with fork ID, it doesn't contain related properties. It doesn't hash related properties that are related to EIPs but are not transition numbers. So for example, it doesn't hash deposit contract, it doesn't hash blob spec changes, right? Max block changes, etc. So what we should have is some kind of format. We can, like I said, think of extending fork ID or changing fork ID to actually kind of create a hash of our current configuration, and based on this hash, we can compare it between us easily. So that's my counter proposal. It doesn't have to be counter proposal because it can be like complementary. We can also switch to the chain spec for the same notice format. So it's like, but it's, I think this is the actual solution to some extent rather than just something that doesn't have to work.
One question I had there is, I agree conceptually this seems very reasonable. In practice, how do we agree to the list of configs? And I think we would have probably caught this one, but there's maybe a way where like the deposit, I was looking through the EIPs and the deposit contract address, I think in 61110 is like set for mainnet, but it doesn't specify the other ones. So I think, whereas like all the system contracts are actually specified like in the EIP and there's like a clear address there. So I think one challenge, if we do implement this, is what's the process to make sure everything is like included and that we don't just quote like assume the deposit contract, is going to be fine, which obviously after this week will no longer happen. But I could have imagined a case where we had this prior to Pectra, and then we add all of the precompiles, or sorry, all of the system contracts in, but we don't actually include a deposit contract because the deposit contract's already been deployed on chain, and it's not actually something that like we've added. So yeah, Lucas.
So I think we need to identify something that we can call EIP parameters that can potentially change between EIP, implementation, well, maybe not implementations, but instantiations of different networks. And everything there under this should be included in this kind of hashing mechanism.
Yeah. I think
so it's probably worth mentioning on the consensus layer, we've tried to do this. Every node has a standardized API that dumps a configuration, and theoretically everything should be possible to look at and compare. But in reality, it's nowhere close. There's multiple different sets of parameters. There are old parameters from prior forks, so there's a whole bunch of stuff like that. So I think that absolutely we need to do this. I have no doubt that it's another test that we can do. I mentioned in the chat we can compare either against a single source of truth that everyone can look at and understand, or they can cross compare the clients just to make sure they're the same. But it's going to require specification. It's just going to take a little bit of time and effort to do so. So, like we said, even on the CL side, which theoretically has this already, it's a long way from being baked in. And it's like we said, there's a whole bunch of even stuff as ludicrously simple as that. But we have some execution addresses that are in lowercase hex and some that are in the IP55 format. So, absolutely we need to do this. I would not underestimate the amount of work that it might take to get there.
Yeah. So we're at time. Does anyone have the bandwidth over the next 2 weeks to investigate what this could look like and what the actual issues would be? If not, then sorry.
I mean, look, yeah, we should probably go for it. My view is, again, I think we start with this consensus layer because it's a smaller problem. It's more bounded. There's less sort of old APIs and old configuration formats, right? But I think that will give us, if we do that for the CL side, that will give us some good learning and good information to be able to then sort of take to the execution layer side, and then start working on that. Look, I mean, this is not a time critical item. I think we can manually check for Sepolia. I think we can manually check for mainnet, even though theoretically things haven't changed, but we'll do that. I think this is something that should be ready for, the Fusaka test nets.
Yep.
So, I mean, I'm happy to start kicking that off and talking to people about it and putting up docs and stuff. But, like we said, this doesn't feel like something that needs to be done pre-Pectra.
Yes, I agree with that. Yes, and then so thank you, Dano, for stepping up. So I think yes, we should target this for Osaka or later, and we should probably also use Spectra and maybe even the fork before Denkun as what would the diff have been and basically just use them as old test cases. But I agree we shouldn't not ship Pectra until we have this, but improving for at least the next fork would be good. Okay, we're already a few minutes over. I know we had more on the agenda, but I think we covered the four most important parts. So we know what's happening with Holesky in the next 24 hours or so. 15 UTC tomorrow, we'll have a call to disable the slashing protections. Hopefully have enough validators online before that. We know that we're keeping Sepolia fork, the Sepolia fork happening at the same time. There's 4 clients that need to be updated in the blog post. I will do this within the next hour. And then on the CL side, the biggest short-term engineering fix is this idea of the custom checkpoint that POTUS presented. On the EL side, figuring out how to harmonize constants and parameters that go into a fork and test for that feels like the highest impact thing. And then looking into, can we actually standardize the config files? But there might be some trickiness there. So if there's a way to actually test that every client uses the same configs regardless of their of the format of their Genesis file, that might be more robust. Anything else people feel is urgent to bring up before we wrap up today? Okay, well, thank you very much, everyone. Appreciate the work over the past week or so trying to get Holesky back up and running. Let's see how things go tomorrow, and I'll post some updates on the Discord as we get them. Talk to you all soon.